I've been asked to come up here so that you can see me. I don't know why. Um, Our next speaker is Angel Pizarro from Amazon. And Angel, the same sort of thing. 10 minutes presentation and 5 minutes for questions. Thank you.
Okay, great. Thanks for inviting me here. And the introduction you gave Dixie was almost spot on, exactly what I was going to talk about. Somebody said the big green arrow. Yeah. That's what I'm pressing. The little one. Yeah, that's what I was pressing. All right, anyway. So the elasticity, right? So thinking about how scientists actually work, when they're working on data, when they're working on experiments, they tend to have cyclical workflows. I believe that operational models like clinics tend to have a more standard set of data that they analyze on a per day, per week, per month basis, so they can do pretty good capacity planning. But then you get to a point where you want to do a big cohort analysis or recompute what the background distribution would be for your population, and suddenly you have a problem of not having the type of compute or the size of compute that you'll need for new problems. And that's essentially why you would want to consider something like Amazon. We're a global, for folks that don't know, Amazon Web Services is a global provider of IT on demand. You pay by the hour, there are no commitments. And we've got tremendous scale. And because there's no commitments, you're able to elastically go up and down with the size of, be able to provision the size of compute that you need to the problem. So I was asked to talk about solutions. That is the solution, to be on-demand scalability of computation when you need it for what you actually want to do. But today I'm going to be talking about, since this is the Global Alliance, collaboration on a global scale. And part of the reason you'd want something like a global provider like AWS is our global accessibility. And on top of that, the security model behind why we think we have a good platform for genomics and life sciences in both the research perspective and the clinical perspective. So this is the AWS Global Footprint. Each one of these markers here represent a region that we've built out. What I'd like to point out here is a couple of things. One is that for each individual region, they are operated by a regional team and a regional business within the borders of that country. And when you place data within one of these regions, it stays there until you take it out. The other thing I'd like to point about all of these regions spread around the world is that every day all of these regions are growing at a really rapid pace. When we took a look at the numbers, we realized that every day we install enough new infrastructure into our into our regions to support Amazon.com when it was an $8 billion, $7 billion business. That's a lot of infrastructure. And you've seen a lot of maps today. I'm going to show you one more map. This is a site called Omics Map. It is self-reported sequencers around the world. And if you notice from the previous map, we tend to have regions in every single one of the high-density regions of where sequencers are, which is a pretty interesting problem from a correlation versus causation, but it'll be one of those too. So our goal with this talk is look at what it takes and what are our motivations to enable collaboration across institutions. And basically, there's two principles that you want to have. You want to easily and securely share data and applications as well that go along with those data across institutions. And you want to be able to publish pre-configured resources out to the community at large so that they can take advantage of. And both of these are goals of the Global Alliance. So before cloud computing, before you had these mega scale providers, folks who had infrastructure and wanted to share data and add collaborators would essentially need to copy data from one place to another, and that other place needed to have equivalent infrastructure or larger to be able to handle the problem. And that was okay for a very long time. And then you started getting petabyte scale data sets like the cancer genome data sets. And this model didn't quite work because it got repeated over and over again. And not everybody is MIT or the Broad or other institutions that have quite a lot of money to resource computation. So you have this sort of two-tiered system of being able to get access to actually even do population scale science, which isn't good for the world. And in particular, too, even if you had the infrastructure, or you bootstrapped your own private cloud, or if you even bootstrapped things on top of Amazon Web Services, the model really was a download copies, compute on it on your local resources, and essentially introduce divergence into data sets. So you weren't really sure if something was called this particular sample and this particular data, if it really was that thing. So after folks got savvy about AWS, they started looking at a different model where they would put data within a cloud infrastructure. They'd request and give access to the collaborators on a temporary space, increase the infrastructure that was necessary to handle that additional load. But more importantly, when the collaborator went away or the project stopped, they were able to just get rid of the infrastructure and stop paying for it. And that's a really powerful model. And it didn't preclude any other sorts of models like ingesting new data from new collaborators or sending the data out. You still had the flexibility to do the models that you were used to and work with it. So I think this is where we want to get to as a regular course of business. So that's exactly what National Database for Autism Research did, is they had an environment within AWS where they stored their phenotype data within one of our services called Relational Database Service, as well as the larger data within an object storage service that we call S3. And collaborators that want to come in and use that data actually supply AWS credentials to Endar, and Endar bootstraps many little clouds for that collaborator within AWS. Endar is not paying for this, right? The actual individual researcher is paying for this. So now you can bring in an individual and collaborator resources extremely easily and add them to the project. They get the value out of your data set. You collaborate with them and actually share your knowledge. But on top of that, they can take, bring their own processes into this environment. Not only that, they can take advantage of a giant open source science ecosystem that's already on both our platform and others. Things like Docker containers where folks are wrapping the Tuxedo suite for RNA-seq analysis. There's whole working groups that are created these days that are looking at publishing pre-configured pipelines for cancer genome analysis. You have image analysis tools like this coming out of Nitric. And then next generation tools like the UC Berkeley AMP Lab, who's doing development of Spark-based tools. So the goals for our collaboration essentially are met by using an infrastructure, mega-scale infrastructure provider. We're able to publish pre-configured resources. We're able to bring on collaborators at will, as long as, with different models for paying for it. And you're able to easily and securely share those data and applications. But not only that, you take advantage of huge resources that wouldn't be there unless you had the time and effort to put it into your own infrastructure. And that's not all, right? I feel a little bit like a late night TV selling guy. You also have this giant ecosystem of commercial partners that's on top of our platform, building vertical solutions that would take advantage of not just our infrastructure, but also the problem domain at large. And in particular, this middle band of providers has platforms as a service for genomic analysis. You have some downstream analysis tools here as well as generalized computational partners. I'd like to highlight two of them. One of them is Seven Bridges Genomics. They won the one of the NCI Cancer Cloud Pilot Awards. You can find out more about them here at the cancergenomicscloud.org. Another partner of ours, DNA Nexus, is in the audience as well. And you see this model where you're bringing a collaborative space into the commercial sector as well, not just it's not just academia and academic institutions that want to collaborate over data. You also have a strong motivation from the commercial sector to be able to do these things. My last topic, how am I doing on time, Dixie?
You have 5 minutes, including questions.
Okay, I'll go through this really fast. So genomic data security. Dixie mentioned that there is new models of security, and this is the way that AWS thinks about security in a nutshell, is that it's a shared responsibility model. Us as the infrastructure provider tends to focus on the services and our service offerings and offers extremely strong security guarantees, or as close to guarantees, third-party audit standard operating procedures for our security that is industry leading. And that includes facilities and compute infrastructure as well as our service endpoints. But since we don't take a look at customer data as a course of business, right? We don't actually want to know what you're running on our systems. You control all the risk mitigation strategies in that risk envelope. And therefore, you have to step up and be your own security advocate of how secure something is. So you take our security procedures, add them to your own, have a third-party audit, and at the end, you should have a fully audited solution. So within that context, we took a look at the dbGaP security requirements, the SSPs, the NIST protocols, and then did a crosswalk over to AWS and how you meet those security requirements. And this is a 17-page white paper. If you're a little bit jet-lagged and have insomnia tonight, go ahead and download it. I'm sure it'll help. And this is my final slide. I'll leave this with one thing, and this is sort of a personal statement, is that I really think that borders might be getting in the way of progress. And that I put the challenge to government organizations out there to, yes, it's your role and duty to protect the rights of the individual, but it's also your role and duty to make this data available to the community at large and population at large. We are one world. I'd like us to be able to share what we know with the rest of the world as well. Thank you.